Hello class, this is the second part of lesson 9-1 in your book about learning how to graph a function, quadratic function that looks like y is equal to ax squared plus c. If it was just ax, it would be linear, but it's quadratic, and yesterday we practiced graphing these, which look like a U-shape. That U-shape we call it a parabola. Now, the ones that we graphed yesterday were of the form y is equal to a, so some number, x squared, and that number was bigger than 1 when we took the absolute value of it. So the parent quadratic function that we graphed over and over and over again was this one right here. So I'm going to plot those points for you just to remind you. Look something like this. Very nice U-shape. And what we learned was when the number before it was bigger than 1, when we took the absolute value of it, it was much narrower. So it may have looked something like this. Or it may have even been an upside down parabola if it had a negative number. So all of those, it looked like it was much more narrow compared to the parent quadratic function. We also did other ones of the same form, but this time the number in front, when we took the absolute value of it, was less than 1. So this typically looked like a fraction between 0 and 1, like 1/2 or 1/3, -1/4. All of those would fit. So again, if we had our parent linear function, I'm going to plot those points for you. This is just a reminder. Now it looked like this. Very nice U-shape. But when we graphed ones with that fraction, we learned that it was typically much wider. Right? And we could know that before we even begin graphing it, what to expect. That it would be something that would be much, much wider compared to that parent one. All right? So let's think about that. We're going to do one more new concept today. And what today is going to be getting back to this form, y is equal to ax squared plus c, but instead of the c being 0, because we never had a c here, this time we're actually going to have a c that is not equal to 0. So I have two examples for us today. The first one is y is equal to x squared plus 3. Okay, so this time my c is the number 3. I'm going to add that to whatever I'm going to square. So if I plug in -2 here, -2 squared is 4. 4 plus 3 is 7. Plug in -1. -1 squared is 1 plus 3 is 4. 0 squared is 0. 0 plus 3 is 3. This is the first time I haven't had 0, 0. Plug in 1. 1 squared is 1 plus 3 is 4. Plug in 2. 2 squared is 4 plus 3 is 7. I'm going to graph all of these points now. So I have -2 up to 7. -1 up to 4. 0 up to 3, 1 up to 4, and 2 all the way up to 7. So look at that. Looks like now the vertex of this is going to be right here at 0, 3. And this looks very similar to the parent quadratic function that I had, except it looks like it's just moved up on the y-axis beginning at 3. If I had that parent linear function, or parent quadratic function, these are not linear functions, it would be at -2 up 4, -1 up 1, 0, 0, 1, 1, and 2 up 4. And if I was going to show you that parent quadratic function, it would be right here. And it does look like it is the same shape All right, it's just moved up, so it's no wider or narrower. It's just moved up on the y-axis. So what do you think if we subtract 2 for this next one, y is equal to x squared minus 2, what do you think is going to happen? I'm going to choose some points again, -2, -1, 0, 1, and 2, and let's plug those into the function. -2 squared is 4, minus 2 is 2. -1 squared is 1, 1 minus 2 is -1. 0 squared is 0, minus 2 is -2. 1 squared is 1, minus 2 is -1. 2 squared is 4, 4 minus 2 is 2. Let's plot these points. -2 and up to -1 down to -1, 0 down to -2, 1 down to -1, and 2 up to +2. Look at that. And it looks like it is still the parent linear function, sorry, parent quadratic function. I'm having a day with that. Except that it has moved down -2. Right? Do we see that? So the rule, or the lesson that I want you to remember for this section is that when you are graphing a quadratic function where it looks like y is equal to x squared, which is the parent quadratic function, plus a number that is not equal to 0, you're going to move your parent function either up or down on the y-axis. And that's it. So we're going to get a lot more practice with this when we get to class.